To collect avian abundance and species richness data, we used 10-minute dependent double observer point counts, where all birds seen and heard within a 100-meter radius were recorded. These counts were conducted in a 3-hour window after dawn when birds were most active, between May through December 2016 and 2017, and May through July 2018. Data were analyzed using a 3-level hierarchical multinomial model and a model selection framework that accounted for abundance or richness, availability of birds to be detected based on things like time of year and weather, and then detection itself, which accounts for things like observer differences. Relationships between species or richness and landscape gradients were analyzed at 3 spatial scales, 100 meters, 500 meters, and 1,000 meters, and then also across all 3 scales as well. Candidate models for each scale and across scales were constructed from a suite of landscape gradients, which you can see here on the screen, and then we interpreted the model with the highest AIC weight. In total, we visited 301 randomly stratified sites across the landscape, where we detected 10,399 total individuals of 280 different bird species. We then constructed a best model at each scale for each species and grouped them into different feeding guilds to look at how diet and foraging stratum affect avian responses to some landscape gradients pertaining to fragmentation. As you can see here, there's a lot of variation both between and within different guilds, but some key patterns that we can see is in this very steep study area, elevation plays a really critical role in which species are going to be present where. And also all species responded positively to the amount of forest cover, as we would expect from forest-dependent species. For some species, particularly some canopy frugivores, canopy insectivores, and some understory insectivores, edge density was actually very important. A lot of these birds preferentially forage around the forest edge because there's an abundance of aerial insects as well as small fleshy fruits. So these birds' diets are tied to edge density, particularly at finer spatial scales. For today, we're just going to focus on 2 examples to get into a little bit deeper into some of the analysis. The first is an understory frugivorous forest-dependent bird, which is the long-tailed manakin. You can see the best cross-scale model for this species here. So this actually, rather than looking at the individual scales separately, is a best overall model with landscape gradients of all different scales. So you can see that these birds respond to some key gradients at different scales. And here we've created a map of predicted long-tail manakin abundance across the study area based on this best model. Similarly, we analyzed forest bird species richness as a whole and created a best cross-scale model for that as well, and also predicted that across the landscape, which we're going to use in our scenarios here in the next box.